Good morning, dear students. Welcome back to physics class. In today's class, I introduce you a new topic. It is Bernoulli's principle. Let us discuss on Bernoulli's principle at first. What is Bernoulli's principle? The Swiss physicist Daniel Bernoulli developed a relationship of pressure difference with kinetic energy change and potential energy change in a fluid flow. You should understand it shows a relationship of pressure difference between 2 points in a region through where a streamlined fluid flow with velocity changes or kinetic energy change and height changes or potential energy change. This relation or the expression is called Bernoulli's equations. According to Bernoulli's principle, the sum of the pressure P, the kinetic energy per unit volume rho V square by 2 and the potential energy per unit volume rho GH remain constant for a streamlined fluid flow. What is the expression for kinetic energy per unit volume? You know that kinetic energy is equal to 1 by 2 mv square. When it is divided by V, we will get rho V square by 2 as mass per unit volume m by V is equal to density rho, and the potential energy per unit volume is mgh divided by V. So it will be rho gh. Then what is the mathematical expression of Bernoulli's principle? It is P plus rho V square by 2 plus rho gh is equal to constant. We can derive the Bernoulli's principle by applying the law of conservation of energy. You should note that Bernoulli's principle is only applicable ideally to fluids with zero viscosity or non-viscous fluids. There is one different term. It is viscosity. You should know its definition now. What is viscosity? Normally, while a fluid flow, the different layers of the fluid flow with different velocities. These layers exert frictional forces on each other, resulting in a loss of energy in the form of heat energy. This property of the fluid is called viscosity. So, for deriving the Bernoulli's principle or the Bernoulli's equation, we have to assume that there is no loss of energy due to the friction. Assume that the fluid flows through a pipe of varying width. The pipe is located at changing heights. The fluid is incompressible. The fluid flow is laminar and there is no loss of energy take place due to the friction. We have considered the fluid is a non-viscous fluid. Consider a fluid of this kind moving in a pipe of varying cross-sectional area. You know that its velocity must change as a consequence of equation of continuity, which is AV is equal to constant, where A be the area of cross-section of the pipe at a point and V be the velocity of the fluid at this point. The figure given in this slide shows the flow of the ideal fluid in a pipe of varying area of cross-section. Suppose the fluid initially lying in the region between B and D as shown in given figure. In an infinitesimal time interval delta t, this fluid would have moved. Let us consider V1 be the speed of the fluid at the point B and V2 be the speed of the fluid at the point D. Then what is the initial distance moved by the fluid from the point B to C? It will be equal to its speed into time interval. It is V1 delta t. In the same interval of time, delta t, the distance traveled by the fluid from the point D to E is equal to its speed into the time interval. It is V2 delta t. Let P1 be the pressure of the fluid at the first end of the pipe of area of cross-section A1 and P2 be the pressure of the fluid at the second end of the pipe of area of cross-section A2. Then what is the work done on the fluid at left end BC, which is W1 is equal to force into displacement, as force is equal to pressure into area, since pressure is equal to force per unit area and the distance be the velocity into time. It is equal to P1 A1 into V1 delta t. Similarly, what is the work done by the fluid at other end DE? Let it be W2, which is equal to minus of P2 A2 V2 delta t. Then what is the net work done on the fluid? It is W1 plus W2 is equal to P1 A1 V1 delta t minus P2 A2 V2 delta t. You know that equation of continuity is AV is equal to constant. This constant is the volume flux or volumetric flux. It is the rate of volume of the fluid flow across unit area, or it is the volume of the fluid flow across unit area divided by the time interval. In this case, the time interval is delta t. In this time interval, the volume of the fluid flow across both regions, which are BC and DE respectively, are the same. Let it be delta V. You should see the same volume of the fluid delta V pass through the both regions BC and DE in the same time interval delta t according to equation of continuity. So, the net work done on the fluid is W1 plus W2 is equal to P1 delta V minus P2 delta V, where A1 V1 delta T be delta V and A2 V2 delta T be also delta V. Since A1 V1 is equal to A2 V2 is equal to delta V by delta T in accordance with equation of continuity. Therefore, the net work done W1 plus W2 is equal to P1 delta V minus P2 delta V. Then W1 plus W2 is equal to P1 minus P2 into delta V, which is the expression 1. You should see that part of this mechanical work goes in changing kinetic energy. So, delta K is equal to 1 by 2 m into V2 square minus V1 square. And part of this work goes in changing gravitational potential energy. Let it be delta U, which is equal to mg into h2 minus h1. Then, what is the total change in the mechanical energy? Let it be delta E is equal to delta K plus delta U. That is, change in kinetic energy plus change in potential energy. It is equal to 1 by 2 into m into V2 square minus V1 square plus mg into h2 minus h1, which is the expression 2. Let delta m be the mass of the fluid passing through the pipe in time interval delta t. Here we have to replace m by delta m, and the equation 2 can be modified as delta E is equal to 1 by 2 into delta m into V2 square minus V1 square plus delta mg into h2 minus h1, which is the expression 3. As density of the fluid rho is equal to mass per unit volume, then mass is equal to density into volume, which is rho V. So, in this case, delta M is equal to rho delta V, which is the expression 4. Putting the value of delta M from the equation 4 to the equation 3, we get delta E is equal to 1 by 2 into rho delta V into V2 square minus V1 square plus rho G delta V into H2 minus H1, which is the expression 5. Delta E, and by using the equations 1 and 5, we get P1 minus P2 into delta V is equal to 1 by 2 into rho delta V into V2 square minus V1 square plus rho G delta V into H2 minus H1. So, P1 minus P2 is equal to 1 by 2 into rho V2 square minus 1 by 2 into rho V1 square plus rho G H2 minus rho G H1. Here, the delta V's are cancelled on both sides of the equation. After rearranging the terms in the expression, we get P1 plus 1 by 2 into rho V1 square plus rho G H1 is equal to 1 by 2 into rho V2 square plus rho G H2. Then P plus 1 by 2 rho V square plus rho G H is a constant. This is called Bernoulli's principle. In the Bernoulli's equation, P is the pressure, 1 by 2 rho V square is the kinetic energy per unit volume, and rho G H is the potential energy per unit volume. So, the sum of the pressure, the kinetic energy per unit volume, and the potential energy per unit volume is a constant for a streamlined fluid flow. Now, let us look into some special cases where the Bernoulli's principle can be applied. First case is when a fluid is at rest. This means that initial velocity and final velocity always will be equal to 0. That is, V1 is equal to P2 is equal to 0. We have the Bernoulli's equation, which is P1 plus 1 by 2 rho V1 square plus rho G H1 is equal to P2 plus 1 by 2 rho V2 square plus rho G H2. When the velocities V1 and V2 are equal to 0, the Bernoulli's equation is changed as P1 plus rho G H1 is equal to P2 plus rho G H2. Then P1 minus P2 is equal to rho G H2 minus H1. This is the Bernoulli's equation of a fluid when it is at rest. And second case is when the pipe is horizontal, then its height is not varying at anywhere, that is H1 is equal to H2. This means that there is no change in its potential energy by virtue of change in its height. So the Bernoulli's equation becomes as P1 plus 1 by 2 into rho V1 square is equal to P2 plus 1 by 2 into rho V2 square. By simplifying this expression, we get P plus 1 by 2 rho V square is equal to constant. Today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.